Good morning, students. Mr. Suluk here, coming up with lesson number 3 from the Gear and Simple Gear Trains presentation. We're going to move into something called idler gear. The idler gear is a gear that can be placed in between the driver gear and the driven gear. The gear ratio will remain at 1:1 when the idler gear is used. For different size driver and driven gears, the idler gear will have no effect on the total gear ratio between the driver and the driven gears. The idler gear only changes the direction that the driven gear rotates. So if the driver gear goes in a clockwise rotation, the idler gear would be forced to go into a counterclockwise rotation. Thus, the driven gear would end up going in the same direction the driver gear. So clockwise, counterclockwise, clockwise. For gear trains of 3 or more gears, the total gear ratio should be calculated before the driven gear speed is determined. Driven gear speed in a 3-gear train. The gear ratio between the driver gear and the idler gear can be calculated by 12 divided by 24, or 0.5 or half to 1 or 1 to 2. The gear ratio between the idler gear, this one right here, and the driven gear can be worked out as 12 over 18, or 18 divided by 12, or 1.5 to 1. See, that idler gear is a little smaller than the driven gear. It would make sense that it would have to rotate more in order to keep up with the driver and driven gear. So the total gear ratio here is driver gear to idler gear times idler gear to driven gear. So an example here is the ratio between driver and idler is 0.5. The ratio between idler and driven gear is 1.5, or when we multiply this, it's 0.75 to 1. Okay. Driven gear speed in a 3-gear train. The total gear ratio can also be determined by one single calculation. Driven over driver, okay? Driven is at 18. We're going to put 18 in the numerator, 24 in the denominator. When we reduce this down, it's 0.75 to 1. Okay? This shows that this idler gear does not affect the overall gear ratio. If the driver gear rotates at 45 rotations per minute, the driven gear will rotate at 60 rotations per minute. So if this guy is going pretty fast, let's say at 45 rotations per minute, and given the fact that the driven gear is smaller than the driver gear, and we already know the idler has no effect on the speed at all, this driven gear is going to have to go faster in order to keep up with the driver gear. Okay, just based on size. This is the math behind it. But as you can observe, this driver gear, because it's larger than the driven gear, is going to push this driven gear to go faster. So, question. What is the gear ratio of the gear train shown below? A, 4 to 3, B, 3 to 4, C, 2 to 3, or D, 2 to 1? The best answer is A, 4 to 3. What is the speed of the driven gear? A, 120, B, 40, C, 30, or D, 10? The best answer is, oh, I'm sorry, clicked the wrong one. Should be 30 rotations per minute. So I realized this was a pretty quick one. The next virtual lesson, we're going to do a complete overview or review of everything that we've learned so far on gears and simple gear trains. We'll have an online worksheet to complete, just some extra practice just to reinforce what we've learned. But in the last 3 presentations now, we've gone over simple gear trains. We've learned about gear ratios and gear speeds, how to calculate gear ratios, how gears can be used to speed up and slow down rotation. We also learned about idler gears today. Thanks for watching. Please make sure that you completed all 3 of the questions today and hit turn in when finished. Have a great day.